guys, welcome to Sopowers channel. Today we are going to talk about the 5 components of a drone. Firstly, the power system, which is the heart of a drone. It includes the battery, the BMIs, and the power board. The battery decides how long the drone can fly, how much power it can deliver, and how well it performs in different conditions. The BMS is like the brain of a battery. It monitors current, voltage, and temperature, keeps every cell balanced, and protects from overheating or deep discharging. The power board is like the hub that distributes electricity from the battery to the ESCS, the flight controller, and all other modules. It keeps the power flow stable and prevents voltage drops during heavy load. Secondly, we will talk about the propulsion system. It includes the motor, the electronic speed controller, and the propeller. Together, they decide the drone's thrust, efficiency, and flight noise. The motor is like the muscles of a drone. It determines how fast the drone can fly and how much weight it can carry. The ESC connects the battery and the motor. It adjusts the motor speed based on commands from the flight controller, just like a throttle system. The propeller is like the wings of a drone. Its size, pitch, and material directly affect the thrust and power consumption. Larger propellers create more lift but use more energy, while smaller ones are more efficient but carry less weight. After getting the power to fly, a drone also needs a small brain to stay balanced. The sensing and control system is the brain and eyes of a drone. It includes the flight controller, the GPS RTK module, and the obstacle sensors. The flight controller receives commands, calculates altitude, and adjusts the motor speed to keep the drone stable and balanced. GPS and RTK helps the drone know where it is, providing precise positions and automatic return to home. Obstacle sensors use infrared laser or vision technology to detect surroundings, helping the drone avoid collisions and fly safely. Working together, these systems allow the drone just not to fly, but to fly smoothly and accurately. Now that the drone can stay steady, it's time to make it see what's around and talk to the pilot. The transmission and the communication system lets the drone see and respond. It includes the video transmission module, the communication module, and the antenna system. The video transmission sends real-time images from the camera to the ground, deciding how far and how clearly the pilot can see. The communication module handles flight control signals and mission data. The antenna system keeps the signal stable and helps reduce interference and delay. The payload and mission system gives the drone a real purpose. It includes a gimbal camera, thermal sensors, LiDAR, and spring-on-delivery modules. The gimbal camera is used for aerial photography and video shooting, keeping images stable in flight. Thermal sensors are used in agriculture, inspection, and rescue to detect information invisible to the human eyes. LiDAR scans terrain with lasers to create 3D maps, and spring-on-delivery modules let drones perform agriculture or logistic tasks. Different payloads define what the drones can do, and that make it not just fly well but work smart.